Alright, we're doing the remainder factor and the remainder theorem and factor theorem. We're looking at those and looking at it with the view of factorising cubics. And just need to recall from our factor theorem, if we've got some given polynomial p of x, and if we have p of alpha and that equals 0, x minus alpha is a factor. So that's something we've seen previously. If we have a look at an example here, while this is not a proof, it demonstrates something. If we have x cubed minus 2x squared minus 5x plus 6, that can be broken down into two factors such that one is a quadratic, and that's the factor on the right hand side there, and we would have x minus alpha on the left, okay, which is our generic factor which we've seen before. So suppose that's the case, and if we expand that out, we will get the following. We get ax cubed plus bx squared plus cx minus alpha a x squared minus alpha b x minus alpha c. So collecting like terms, ax cubed, now the squareds, we have plus b take alpha a x squared plus, for the x terms, we have c minus alpha b x minus alpha c. So where it's at is here, so we have that corresponding with that. So that would mean that negative alpha c equals 6, or alpha c equals negative 6. Therefore, c equals negative 6 over alpha. And we know that alpha is an element of integers. So that means alpha divides negative 6. And if alpha divides negative 6 and alpha is an integer, alpha is a factor of 6. And think of your definition of what a factor is. So therefore alpha is one of these factors of 6, positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 6. So it could be one of those. So this leads on to the main strategy for what we're trying to do here. We're going to try alpha candidates, or possible potential values for alpha, until you find the one that makes p of alpha equal to 0. See above. That way we have identified a factor, and once we've identified a factor, then we can start dividing. Once we have a true factor, we can start dividing our polynomials to find the other factors. So what that means for this example showing here, factorise as cubic, means we've got to find our value for alpha, and remember it's going to be a factor of c. Okay, so alpha is a factor of c, and our c value is positive 6. So think about all your factors are positive 6, and because it's the same polynomial, we've actually already done that step. So I'm going to start at the most obvious one. Try all of your p of alpha values. So to get alpha, let's try p of 1. You don't have to start there, but I think that's a fairly obvious place to start. So we sub 1 in for x. So we have 1 minus 2 minus 5 plus 6. So negative 1, negative 6 plus 6, yes, that equals 0. So that means alpha is 1. We found it straight up. Doesn't always work that way. And alpha is 1, so x minus alpha, or x minus 1, is a factor. Bingo! So we can do that factorising because we know one of the factors. We can chase the other ones. So we're going to fully factorise now by dividing through by x minus 1, x cubed minus 2x squared minus 5x plus 6. And we've seen this in previous videos, the algorithm we use. Okay, so we've got negative 2x plus 1x, sorry, negative 2x squared plus 1x squared. Bring down the next term. Times by negative x. Bring down the plus 6. So we need to times by negative 6. Yep, that makes sense because it was a factor. There should be a remainder of 0. So what we have here then is x. There's no remainder to juggle with, so it is, and we're dealing with a true factor, so we don't have to write our answer in that way that we have been in the previous videos when there is a remainder. There is no remainder here. It's an easy to attain factor, and it is x squared minus x minus 6. Now, you might have seen in a previous video, cubics must have 1 or 3 roots or solutions. So basically the roots, is it 1 or 3? Well, we need to see if this bit here can be factorised. Let's try that. So we've got x minus 1, and we're looking for two numbers that multiply together to be negative 6 and add together to be negative 1, and one must be negative, one must be positive if what they multiply together is a negative. The signs are different, in other words. So if we have x minus 3, x plus 2, let's check that out. Negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. So we have our fully factorised cubic, and we have 3 factors there.